Hello and good day, pre-algebra. We're back with PO22, solving equations with variables on both sides. Yesterday, you were kind of introduced to this concept here. You had a quiz on it. Every one that I saw, I got 5 out of 5. Most people took once or twice to take it, so that was good to see. Today, we're going to kind of look at some of the quirks that can happen when you've got variables on both sides. In addition to then looking at any type of equation you might come across. Might have to combine like terms, might have to use the distributive property, might have variables on both sides, or a combination of any of those three. So you've done it. You've reached the summit. You've reached the mountaintop of solving equations. Now we just get to practice some more, because why not? But we're going to start, like I said, with looking at some of the quirks. And the biggest one is what happens when you have the same number of variables on each side. Every equation that you had to solve yesterday, there's a different number, right? We could use that basketball score. But what if it's a tie? What if you have 8 x's on the left and 8 x's on the right? If you think about that basketball score, being tied 8-8 is just like being tied 0-0. Right? You might as well not have scored any points. You've got the same number as the other team. Mathematically, if we attack this by using opposite operations and subtracting 8 x's from both sides to move it over, well, 8x minus 8x is 0x on both sides. They essentially cancel out from both sides of our equation. And what we're left with then are just our constants. In this case, -5 and +1. And so the equation we have, -5 equals 1? I don't think so. -5 does not equal 1. Therefore, there is no solution for x in this equation. There's no number that's going to make the equation true. So when you were growing up and your teachers told you, there's always an answer. Well, there's not always an answer. There is no solution here. And the symbol that we can use for this is a 0 with a line through it. So you can either write no solution or that 0 with a line through it. Both mean the same thing. Nothing's going to make this work. And just to kind of prove that to you here a little bit, I'm going to let you copy down some more notes before I get eraser happy. Okay. Just to prove that to you here, let's pick a number for x. Let's say that x is 3, okay? If we test x equals 3, well, 8 times 3 is 24 minus 5 equals 8 times 3, 24 plus 1. 24 minus 5 is 19. 24 plus 1 is 25. 19 is not equal 25. That does not make the equation true. Let's test something else. Let's test x equals 6. 8 times 6 is 48 minus 5. And on the right side, 8 times 6 is 48 again, plus 1. 48 minus 5 is 43. 48 plus 1 is 49. Well, that's not true either. So x can't be 6. Okay? And we could continue to test values here for the variable, and we would find that every single time, notice what's going on here, the right side is 6 greater than the left side. 25 is 6 greater than 19. 49 is 6 greater than 43. That's going to happen every single time. Because if you have the same kind of starting number on both sides, 24, 24, here is 48 and 48. If on the left side you subtract 5 from that number, and on the right side you add 1 to that number, they're never going to be equal. Okay? So that was a really long explanation for the phenomenon that if you have the same number of variables on both sides, in this case 8, and when you cancel those out, you're left with an equation that is not true. -5 does not equal 1. It is no solution. Okay? You will also run into situations where you have the same number of variables on each side, in this case 3x, and again we have this tie, right? Might as well be 0 to 0. Mathematically, if you subtract 3x from both sides, they'll end up canceling out. And so when our x's cancel out, you're left with something like this. 7 equals 7. That is true. Okay? Let's test a couple numbers here. Let's test, we'll do 3. Okay? X equals 3. Going on the left side, 3 times 3 is 9 plus 7. On the right side, we have 7 plus 3 times 3, which is 9. 9 plus 7 is 16. 7 plus 9 is 16. It works. All right, let's test 10. 3 times 10 is 30 plus 7 equals 7 plus 3 times 10, which is 30 again. 30 plus 7 is 37. 7 plus 30 is 37. And we again have an equation that's true. In fact, in this case, any value that you plug in for x is going to make the equation true, because when we canceled out our variables way back at the beginning here, because they're the same number on both sides, when we canceled those out, what we were left with was a true equation, right? Different from the first one. In the first one, -5 did not equal 1, but now 7 does equal 7. And so in this case, you have what's called all solutions. Any number, any real number that you plug in there for x is going to make the equation true. And the symbol for this, watch carefully here, it's like an 11, and then you start with the first vertical line and make kind of like an R with that, right? So watch it again here. 2 vertical lines, start at the back one, connect to the first one, and you have that R symbol, which means all real numbers or all solutions. Okay? So you've seen an example of both quirks, and this is going to happen, like I said, when you've got the same number of variables on each side, which isn't always going to be obvious, right? Here's where we're going to start to kind of look at some equations that have combined like terms, or the distributive property, or variables on both sides, or a combination of that, right? This first one, 5x minus 2x plus 8x, right? Only looking at that left side, I've got multiple x terms, which means I can combine them. I'm not going to use opposite operations here because I'm not moving them from one side of the equation to the other. I'm combining them. I have 5 x's. I take away 2. That leaves me with 3. Then I add 8. That gets me a total of 11. So combining these like terms, 5x minus 2x plus 8x is 11x. And that equals 11x plus 9. And now I look at this and I see, oh, that was sneaky, but I've got the same number of variables on both sides of the equation, which is one of these special ones here. I know that they're just going to cancel out on both sides. And if my 11x cancels out on the left and I'm left with nothing or 0, on the right I'm left with positive 9. 0 doesn't equal 9. And so because this is an untrue equation, it's going to be my no solution. There's no value for x that I could possibly plug in there to make that equation true. The right side will always be 9 greater than the left side. Because on the left side, I've got 11x. On the right side, I've got that same 11x, but I'm adding 9 to it. So it'll always be 9 greater. The last one, oh boy, we get to distribute. Hooray. So 4 times 6x is 24x. 4 times positive 2 is positive 8. On the right side, 8 times 3x is 24x. 8 times negative 1 is negative 8. If you need to review this, you can look back at either PO15 or PO21. In both of those objectives, we covered the distributor property. Okay, but we see here now that we have the same number of variables on both sides. We have 24 x's on both sides. So once again, we've got one of these special types. I know these will cancel out because they're the same. I'm left with positive 8 equals negative 8. This one's a little bit tricky because you see the 24s, you see the 8s, and you might think, oh, it's the same thing on both sides. It's going to be that all real solution. But on the left side, that 8's positive. On the right side, that 8's negative. Those are different values. 8 is not equal to negative 8, right? 40 degrees feels much different than negative 40 degrees, right? They are opposites. They are not the same. So 8 not equaling negative 8, that's not true. It's once again going to be no solution. Okay? You won't see this too often, right? Where you have the same number of variables on both sides, but when you do, it's going to be either no solution or all solutions, and it'll depend on, once those variables are canceled out, what equation do you have left? Is it true? Is it not? Okay. All right. So that's that. That's kind of the quirks of variables on both sides. The lesson today is actually going to focus on solving equations such as these, where you have multiple things going on here. Right? You look at the first one. 8 times n plus 3 equals 6n plus 46. I see the parentheses, and so that's kind of where my focus should always start. And in this case, I'm going to have to distribute the 8 to get rid of them. So 8 times n is 8n. 8 times positive 3 is positive 24. And that's equal to 6n plus 46. I didn't do anything with the right side yet, right? I only distributed on the left side, nothing with the right side, okay? And now I've got variables on both sides. 8 n's on the left, 6 n's on the right. You can think about it as having 2 more n's on the left, or mathematically, subtracting 6 n's from both sides to cancel them out on the right will leave me with 2n plus 24 equals 46. Whether you do it mathematically or kind of logically, you'll end up with 2 more n's, or positive 2 n's on the left side. And remember, we are using opposite operations here because we are actually moving that term from the right side to the left side. We want to cancel it out from the right side. And now we're in our comfort zone. I hope our 2-step equation. Start with that constant, move it to the other side. That gives us 2n equals 22. Second step, multiply or divide. Divide both sides by 2, cancel that out, get n by itself, and n equals 11. N equals 11. Okay? Very important, actually, that you check these answers, especially with these more complicated equations. It takes a little bit longer, right? But it's worth it. Okay? It can be the difference of whether you get the question right or wrong on a test. So let's just do this quickly here. If I plug n in for, if I plug 11 in for n, I essentially get 8 times 14, right? 11 plus 3 is 14, and I'm multiplying that by 8. On the right side, 6 times 11 is 66. I'm adding 46 to that, okay? Well, 8 times 14 is 112, and 66 plus 46 is 112. So since both sides equal the same thing, I know that I've done it correctly. Okay. Next one, we've got some combining like terms as well as variables on both sides to work with here. Okay. On my left side, I've got that negative 5n and that positive 7n. I'm not using opposite operations here because I'm not moving those terms. They're staying on the same side, staying on that left side. I'm just combining them. And negative 5 plus 7 is positive 2. Okay, negative 5 plus 7, just combine those terms. So you have 3 plus 2n, and that equals 6n minus 1. So I look at this, I don't have parentheses, I don't have any more like terms, I'm down to just variables on both sides. Okay, which side has more n's? And how many more? The right side has 6 n's compared to 2 on the left, so it has 4 more. Mathematically, subtract 2n from both sides to cancel them out on the left. And 6 minus 2 is 4. 3 equals 4n minus 1. Hello, two-step equation, right? Add 1 to both sides. 4 equals 4n. Divide both sides by 4. And n equals 1. Okay. Quick check. 3 minus 5 times 1, which is just negative 5, plus 7 times 1, which is just 7, equals 6 times 1, which is 6, minus 1. Well, 3 minus 5 is negative 2, plus 7 is positive 5, and 6 minus 1 is positive 5. Both sides equal 5, so I must have the right value for n. And lastly here, oh boy, I've got variables on both sides, I've got combining like terms, I've got the distributive property. Let's go, okay? Doesn't really matter which side we simplify first. We've got stuff to do on both of them. So I'll start with the left. I've got 15x's minus 8x's. Okay, can't do anything with that 18. I don't have any other constants here. But I've got 15x minus 8x. 15 minus 8 is positive 7. So my left side simplifies to be 7x plus 18. My right side, I need to distribute. 3 times 3 is 9x. 3 times 16 is positive 48. Okay? So just a little bit of simplifying here. Remember when we first started back in, was it PO18, just those little one-step equations? And I said, you know, those of you that can do this mentally, kudos to you, but you're going to have to learn the process because eventually we will get to equations you just can't do mentally. Hello, equation you just can't do mentally, right? You've got to have these processes to kind of work it down. There may eventually be a point where you can do it mentally, right? Maybe once you get down to the 2-step, okay, or maybe even here, some of you, but you've got to get these processes down too, okay? So you can kind of simplify it down. Anyway, now I've got variables on both sides. I've got 7 on the left, 9 on the right. 9 is 2 greater than 7, which means I'm going to have 2 x's left on the right side. Here's my 2-step equation. Start with that constant. Move it to the other side. Second step, multiply or divide, and we get negative 15 equals x. For this one, checking it, honestly, I would just go to a calculator and I would type in, 15 times negative 15 plus 18 minus 8 times negative 15, see what you get, okay? And then type in 3 times, parentheses, 3 times negative 15 plus 16, and see if they match there. This one takes a little bit more to check. But you could also go to this step here and trust yourself that you simplified correctly. And then 7 times negative 15 is negative 105 plus 18. 9 times negative 15 is negative 135 plus 48. Okay. Negative 105 plus 18 is a negative 87. Right? Negative 135 plus 48 is also going to be a negative 87. Okay. So if you don't have a calculator, or just want to do more of a quick mental check, that might be the way to go there. But it's always best to go back to that original equation and plug in your value for the variable to see if it works. Okay? So there you go. Those, like I said, that's the summit there. The other thing with 2-step equations that I'm going to throw at you today, because I think you can handle it, are word problems. Where would you actually use an equation with variables on both sides in real life? And you probably haven't been in a situation where you'd use it yet. It really comes up when you're comparing things. You're comparing to cell phone companies. You're comparing, this is the age of streaming, right? You're comparing two streaming packages. You're comparing two cable packages or whatever. So here we have this situation where a video streaming service offers two plans, just straight up $5 per movie or $3 per movie with a $20 monthly fee. So you look at this and you say, well, okay, one company is more expensive per movie, right? 5 versus 3, but then the cheaper per movie company also has a monthly fee. So what you need to decide is, well, how many movies do you watch a month? If you only watch one movie, you're spending $5 with that company, but with this one, you're spending $3 for the movie plus the monthly fee. You're spending $23 with that company. So obviously for one movie, you're just going to pay the $5 for it and call it good. But what if you watch 8 movies per month or 15 movies per month, right? At what point, how many movies do you need to watch each month for it to be cheaper to become a member? At what point does that, does that scale tip? Those of you that usually get maybe summer passes to Valley Fair, if you buy a summer pass and go one time, well, you lost money, right? If you buy a summer pass and go 20 times, well, hey, there you go. That's a pretty good deal there, okay? So what we're going to do is we're going to set up an equation with variables on both sides in order to solve it here. $5 per movie. Remember how important that word per is, right? That's kind of the connection between your coefficient and the variable. So $5 per movie, we'll call it 5M. That looks like SM. My 5s. Why do I use 5? Learn how to write. Okay. So 5M, $5 per movie. When is that going to be the same as spending $3 per movie plus that $20 monthly fee? That $20 monthly fee is a constant because that doesn't change regardless if you watch one movie or 100, right? It's just a flat monthly fee. So here's our equation with variables on both sides, right? To solve this, move our 3M over to the left. 5 minus 3 is 2. 2M equals 20. Divide both sides by 2 to get M by itself. And M equals 10. What that means is that if you watch 10 movies per month, you'll come out exactly even, right? If you watch 10 movies per month, $5 times 10 movies, you've spent $50. With the other company, $3 per movie, or 3 times 10, plus that pesky monthly fee, 30 plus 20 equals 50. So at 10 movies, it doesn't matter whether you become a member or not, you will break even. Okay. So the question being, how many movies would you need to watch each month for it to be cheaper to become a member? Okay. It doesn't actually say which plan is the membership plan. Whoops, I'll fire my editor. But I guess you would probably assume that the cheaper per movie with the monthly fee would be the membership service. So your 11th movie, then, it would be cheaper to pay that monthly fee. Okay, 10 is that tipping point where they are the same. That 11th movie, it'll be cheaper. There's another word problem further on down the line here. I know you're probably getting antsy and anxious to practice this on your own. So one more to talk about here. It says 2 cell phone companies are vying for your business. I'll go with whichever one has the flip phone. But one offers a phone for $400 and a $60 monthly fee. The other one offers a phone for $700 with a $40 monthly fee. Or how many months would the cost of the companies be the same? So you have to decide, do I really like this company? Am I only going with it because it's a flashy deal, and I'll save money maybe in the short term, but in the long run, I'll end up paying more? Or am I going to be with this company, my loyal customer, be with it for years and years and years? At what point, how long do I have to be with this service for it to be cheaper for me in the long run? So, this $60 monthly fee, okay, that's a recurring thing. You only buy one phone, right? So the $400 phone, that's your constant. This monthly fee, okay, $60 per month plus $400. When is that going to be the same as $40 per month plus $700? Because you only buy that phone once. So again, we have a two-step equation to solve here. $60 per month plus the price of the phone. When will that be equal to $40 per month plus the price of the phone? So subtract 40M from both sides. All right, you can tell I didn't leave myself enough space here. That gives us 20M plus 400 equals 700. I'm going to just skip down below here. Move our constant over. Subtract 400 from both sides. 700 minus 400 is 300. Okay. Divide by our coefficients. And M equals 15. So after 15 months, the price of these two plans will be the same. So if you're going to be less than, with this company for less than 15 months, you're probably going to want that cheaper phone, okay? If you're going to be more than 15 months, then you're going to want the cheaper monthly fee. But 15 months is kind of that tipping point, okay? All right. What I'd like you to do for your quiz in the Google. We've got kind of a PO22 part 2 here, solving equations with variables on both sides. You've got 3 rows of 3, so 9 in total. I will choose 5 of these to put onto a quiz. So I'd like you to do the work on this page and then go to the quiz and see which questions I've selected, so you can plug your answer in there. But this is it. This is the, like I said, the summit, the culmination of our work with equations. So do the work on this page, hop over to the quiz, complete that. You must get 100%. Please retake it until you get 100%, and that'll be good. That, folks, is how you math. Do not forget to like and subscribe, and have a great day.